All right, this lesson is on converting mass of A to mass of B. This is going to be a three-step problem, and so you're going to need three conversion factors to complete this calculation. The first conversion factor you're going to need is the molar mass of A, and remember A is your known substance. Next, you're going to use your mole bridge, and in your mole bridge, you're going to have the moles of B on top and the moles of A on bottom. Finally, your third conversion factor is the molar mass of B, and remember B is your unknown substance. The conversion factors for the three-step problems will always come in this order. And here's the template that shows us the plan for converting grams of A to grams of B. Notice the grams of A is your given here, and your given is always going to be the number from your problem. So your given will have units of grams of A. And so we're going to need to get grams of A to cancel out first. So that means the molar mass of A comes as our first conversion factor, and you're going to be dividing by that. So you're going to have to calculate the molar mass of substance A and then plug it in here. And remember that for molar mass, 1 mole of A always will go opposite that. Next, you need moles of A to divide out. So this is where your mole bridge will come next. In order to get moles of A to cancel, you will put your mole bridge as your second conversion factor. This will let moles of A divide out, and it crosses you over to moles of B. The numbers for your mole bridge come from the balanced equation. Next, you need moles of B to cancel. So this is where the molar mass of B comes in. You're going to be multiplying by the molar mass of B. You calculate the molar mass of substance B, plug it in here, and then you're going to do the math. Your setup, you will see your units cancel, grams of A with grams of A, moles of A with moles of A, moles of B with moles of B. Your final unit that does not cancel is grams of B, and of course that's what you're trying to find, so that's how you know you're finished setting your problem up. So you're going to multiply the top row together and then divide by the bottom row. Let's look at the practice problem. This is example number 4 in your notes examples. And the equation does need balancing with a 1, 3, 2, 3. So make sure you put your coefficients in. This question says determine the mass of antimony produced when 0.46 grams of antimony 3 oxide reacts with carbon according to the above reaction. Now, I've underlined the two important parts of this word problem. Mass of antimony, so come up to your balanced equation and find the antimony, and we'll circle it. And then 0.46 grams of antimony 3 oxide. So we're going to find the compound in the equation that matches that formula. Antimony 3 oxide here is Sb2O3. Notice it's a 1-to-2 ratio for the mole bridge when we need that. Now this is going to end up being a 3-step problem. Here's how you will determine that though. When you're working through your problems, you're not going to necessarily know if it's a 1, 2, or 3-stepper until you start with your T-chart. So the given is 0.46 grams of antimony 3 oxide. So of course you're going to always begin with that, 0.46 grams of the antimony 3 oxide. That formula is Sb2O3. You're going to come over and you're going to, on the other side of your equal sign, write down the unit you're trying to find, which is mass, grams of antimony. And that's just SB. So this is a gram to gram problem, grams of A to grams of B. That means it's going to be 3 steps. So this is the point where you set up your T-chart so that you have a spot for 3 conversion factors. All right, so we need the grams to cancel here, and it needs to be grams of Sb2O3. That means we're going to use the molar mass of A first. So we're going to have to calculate that, the molar mass of Sb2O3. So go to your periodic table. You see there's 2 antimonies and there's 3 oxygens. Take a moment to calculate that. Okay, Okay, so when you add these two together, you get your molar mass, and what I got for my molar mass was 291.52. All right, so this is going to let grams of the Sb2O3 cancel. So now we need moles on bottom. It needs to be moles of Sb2O3. This is our mole bridge. In our three-step problem, the mole bridge always comes as our second conversion factor, and it's right in the middle. So moles of Sb on top. Look up at your balanced equation. You have 2 moles of Sb, and look to your Sb2O3, and there was a 1 for that. This lets moles of Sb2O3 cancel. Finally, you need moles of Sb on bottom here, and you need grams of Sb on top. And this is your molar mass, grams per mole. The atomic mass of antimony from the periodic table is 121.76. All right, this is going to let moles of antimony cancel. Notice grams of antimony is what you're left with, and that's what you were trying to convert to. So we're going to be able to just plug this into our calculator now. 0.46 times 2 times 121.76, and then divide by the 291.52. That's going to give you, rounding it to 2 sig figs, 0.38 grams. All right, that's your three-step conversion. I'd like for you to try number 2, or actually number 5 on your sheet, but this is our second three-step problem, on your own, and then I'm going to give you what the final answer is here, but I want you to do this one on your own. For this one, you should get a final answer of 1.5 grams, and you're converting to the H2O2. That'll be your final answer on this one. But I want you to try to set that one up on your own, and then we're actually going to do number 6 in class tomorrow.